Hi everyone, we are live. Welcome to another section of IADevs. Today we had a broader audience with many international friends, which is why we're speaking in English. we have a very special guest who is here to talk about the key topic for developing software with LLMs. But before we get into that, I would like to take a moment to explain why we are hosting this series of online talks. To help me with this, let me introduce my friend Alonso Silva. Hi, Alonso. How it's going?
Hi, how are you? Sorry for I was muted.
Doing good. The goal of this talk is to invite you to an AI engineering conference happening in Santiago, Chile on December 9th.
Yes.
I would like to take a few minutes to tell you about this conference and extend an invitation. And for this part, we're going to switch to Spanish, actually to Chilean Spanish. So even if you speak Spanish, you might not understand everything. But don't worry, I promise it's only take a couple of minutes. So we are going to Spanish. And IADevs es una conferencia que estamos organizando en Santiago. No te la puedes perder si estás en Santiago, si trabajas en IA o quieres trabajar en IA, tienes que estar ahí porque vamos a hablar sobre inteligencia artificial, pero sin humo, no es la típica conferencia sobre con la IA puedes hacer esto, o te vas a sentar y vas a recibir una speech comercial, o te van a tratar de vender un programa académico. No, aquí la idea es que hablemos entre personas que están desarrollando con inteligencia artificial, ver los problemas reales, qué es lo que están solucionando, cuáles son los desafíos y cómo los solucionamos. Vamos a tener invitados de clase mundial. El primero que te puedo anunciar es a mi amigo Alonso Silva, que nos va a dar una gran charla sobre grafos y cómo usarlos en RAG. Alonso, invita a la gente a tu charla.
Sí, vamos a hablar de graph racks y en particular de cómo utilizar los grafos de conocimiento, cómo construir grafos de conocimiento y cómo utilizarlos en Retrieval Augmented Generation, que espero que poco a poco va a volverse un término conocido y utilizando Structured Generation, o sea, generación estructurada.
Súper, ya vamos a saber más de eso. Y también les puedo confirmar que también nos va a acompañar Víctor Navarro de CodeGPT. Es imposible hablar en Chile de IA generativa sin hablar de CodeGPT porque es probablemente la empresa, el startup más potente en ese aspecto en nuestro país y tienen millones de usuarios en su extensión de VS Code. Tienen un montón de proyectos, un montón de clientes y hacen cosas súper sorprendentes para hacer IA generativa, estos tipos de copiloto para código. Y claro que es un problema muy interesante y muy difícil de resolver. Y bueno, Víctor es parte principal de ese equipo que lo está resolviendo, así que nos va a contar cuáles son esos desafíos que se han encontrado. Y bueno, conozco a Víctor personalmente, así que sé que va a ser una charla espectacular. No se la pueden perder. Y para motivar todo esto, estamos haciendo este ciclo de charlas online. Hoy vamos a tener un invitado de lujo, Cameron Pfiffer. Vamos a volver al inglés, so all right, let's switch back to English. Alonso, I'll let you to introduce our guest.
Yes, so Cameron, I don't have the video, but I know him. So he's a developer relation engineer at .txt AI. Basically, it's a company who built this great library called Outlines, and they also have they have implemented it in Rust. They have also implemented some other library like prompts, and yes. So
Cameron,
Cameron, we leave you the floor.
Thank you very much for having me, and also thanks for doing this in English. The only Spanish I know would get me in a lot of trouble, so I appreciate it. Yeah, I'm excited to give a talk today, and I'm happy you guys are doing this conference and everything. So for people who are like in Chile, I'm sure they talked about it. You guys should go hang out with them. It'll be cool. So they're great, and they've been like the Alonsos have been like longtime contributors to the Outlines ecosystem. So I'm happy to be here and hanging out with everybody.
So let's start.
Okay, cool. So so today I'm going to give kind of like an introductory talk for like people who may not have heard of structured generation, partly because it's like kind of a new thing. But I'm just going to kind of give you an overview and how it works and the kind of powerful stuff you can do with it. So I work at a company called .text or .txt. We haven't really decided on the pronunciation. I think it's an ongoing contention from everybody, but it's the file extension. And we make the outlines package, as Alonso mentioned. And outlines is a Python library currently that makes structured generation easy and performant and other stuff like that. But from my perspective, it makes it easy. And that's kind of the most valuable thing for me. But structured generation, the one takeaway you should have is it's how you make AI speak computer, right? So a lot of language model stuff, they're kind of like flimsy and they're like more like toys. And so this is how we take AI from toys to tools. And the way that works is structured generation forces an LLM to output to a specific format. And you can anticipate what this format is because you specified it. So you can write code that responds to the output of the language model without being worried that it's going to format things poorly. So common patterns that you might work with are things like regular expressions, which I'll talk about in a bit, JSON, CSV, programming languages, context-free grammars, anything like this. There's structure in kind of like most forms of text. Once you start recognizing that there's lots of structure, you can just kind of help your language model realize what it's supposed to output without being afraid that it's going to give you nonsense. And the way that people try to avoid nonsense is they do all this stuff here. They give you like examples, or they like try and correct the model, or they say only output JSON or you will be fired. We're big fans of this meme, like, because this explains how people try and get structure, right? They're like, please pick cat or dog, language model. Please don't explain your reasoning. Just give me the word cat or dog. And sometimes that's very annoying, and it'll break any kind of like workflow that you've built. So structured generation is how you program the language models. Okay. So how does it actually work? I get this question a lot, and it's been kind of hard to visualize a little bit because, like normally what I say is like, oh, there's a finite state machine, and it's like a harness on your output layer, and blah, 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 blah. And all that stuff is fairly complicated to explain. But the key thing to take away is that structured generation turns off invalid tokens. It only allows the model to select from tokens that are valid. And an invalid token is one that doesn't match the pattern that we want. And regular expressions, for example, are one way to describe patterns in text. If you don't know what a regular expression is, I'll get to that in just a second. But we know which tokens are invalid using this regular expression. Okay. And so we can use this regular expression because we know which tokens are valid to generate output that matches the pattern that we expect. And so I'm going to show you this example using simplified versions of Chilean phone numbers. So Alonso was kind enough to like walk me through how Chilean phone numbers work. And they're surprisingly complicated. I'm going to show you the easy ones because otherwise it's like hard to, explain it during the talk. But these are common examples of Chilean phone numbers. So you have +56, that's the country code of Chile. Then you have either, we're going to restrict it to be either a 2 or a 9 here. 2, I guess, is for landlines. 9 is for mobile phone numbers, maybe also an 8. And then 4 digits, and then 4 digits. Okay. So this is a kind of a common format for Chilean phone numbers. And of course, these can be any digits between 0 and 9. Okay. So this was also interesting. This is an example of a slightly more complicated pattern where instead of having 1 character here, it's 2 characters, and then that changes this to be 3 and then 4 characters. So we're not actually going to do this example just because it's hard to do, but it's funny because this is for Punta Arenas. Is that how I say it? I don't know if I was close. That's okay. But this is also called the end of the world. So if you need to call the end of the world, this is a good way to do it. But again, we're going to stick to these simpler examples. Okay, so here is the regular expression that describes the pattern that phone number follows. So we're going to have +56. This means that the pattern, the text that we get out from the language model has to start with +56. Literally, the character is +56. If you don't know what this backslash means, that basically says, actually make this the plus symbol in text. Pluses mean something special in regular expressions, so we have to escape it and turn it just to plus. And then the brackets here just mean either a 2 or a 9, and it has to be either 2 or 9. Then we have 4 digits and then 4 digits. And then we have spaces in between them, so it has to look exactly like the digits I just showed you. So \d here just means a number, any digit, and then 4 of those next to each other. So in the previous example, it was 0, 0, 0, 0, 4 digits. Okay, so now what I'm going to do is I'm going to show you how the language model generates stuff according to this pattern. So I'm going to show you the probability of each token being generated at each step, like a list of possible sequences that the model could pick. And then I'm going to pick the most likely structured token. And then I'm going to compare the probability of the structured token that outlines generates and the unstructured token that your language model will just like la-da-da-da-da make up. Okay, so our model starts out strong. Both of them start out strong. So we know the model knows that it's probably going to start with a +5 because the country code for Chile is +56. And you'll notice that they both agree on probability, right? It's roughly 100% probability. For the structured model, it's always exactly 100% probability, or as close as you can get to within floating point. And the unstructured probability is almost 100% here. It's technically non-zero for everything in this column, but it's low probability. So in principle, your model could kind of accidentally select some of these if you're using standard multinomial sampling. And then we're going to step forward a little bit. And now is where our model starts, our structured model and our unstructured model start diverging. The model has to output +5, 6, and then a space, because we told it has to pick exactly +5, 6. It can't use other stuff. And so our structured model is always going to pick this +5, 6 with probability 1. If the unstructured model sees +5, 6, it's actually going to it has some probability on stuff we just like don't want. So like 77% of the time, it's going to say +5, 6 is. And this is the model trying to start explaining +5, 6 in natural language, which is not what we want. We want a number that exactly follows the structure of a Chilean phone number. There's 17% probability that it adds a new line character. There's a 6% it tries to explain using the word followed. And 0% probability on the thing that is exactly the structure that we want it to follow. And then there's always some probability of nonsense. This model actually, this unstructured model has 80% probability of just adding a space after 3 digits, because there is some variation in in like Chilean phone numbers, like how they're actually structured. So it'll try to do this, but that's not according to the pattern we specified. So our structured model will always pick from one of these 2 digits. We just ask for a random number, so it tends to give us like 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. But 78% probability, 21% probability, and 0 probability on the thing that is not according to the pattern we specified. Okay. So this is kind of the last step, where the structured model knows exactly when to stop. It knows to stop generating because it's gotten to the end of the phone number. So this is the sequence that our language model will take. And this is actually the stop character at the very end. So this is when the model will just stop generating and return to whoever called the language model. The unstructured model will keep trying to generate. In this case, it has almost 100% probability of doing a new line, and only a 1% probability on I think in this case, it adds a space character. So it keeps trying to generate. It doesn't know when to stop because it doesn't have that ability. Structured generation allows your model to just stop when it's generated everything. So that was kind of like a conceptual overview, but I'm going to give you an example of how to use code to do this with outlines. And so we're just going to do some imports. So that's the best import of all time. We're going to go load outlines. And then this part, we're actually going to load a model into memory. So I'm going to use phi3 mini 4K instruct. I'm going to put everything on my GPU. And you'll notice here I'm using models.transformers. This uses the transformers inference backend that Hugging Face produces. Transformers is really ergonomic. I tend to use it quite a lot. It's not the fastest, but it is very simple to use. We also support VLLM, which is super fast. If you don't use VLLM, you should try it. It requires a lot of resources, but it's really good. We also support Llama CPP and XLlama and a bunch of other stuff. So if you want a different inference backend, we kind of support all of those. Okay. And another note on this is Outlines works with any open weight model where we have access to the underlying logits, the underlying token predictions. We can make things faster and more structured for you. You can also use OpenAI through this if you're an OpenAI person, but that's not necessarily where our strengths lie because we can't manipulate how OpenAI does it. So this is some convenience stuff. I'm not going to dig into this too much. All it does is take a string and turn it into a special prompt format. Because Outlines doesn't add your like system tokens or your user tokens. If you don't know what those are, that's okay. But this is just some convenience stuff to do that. And then I'm going to set up my prompt. This is a really basic prompt where I'm just going to say, give me a Chilean phone number. And you may note that this is actually not necessarily fair to the unstructured model. And the reasoning for that is I didn't give it a format. I didn't tell it what type of number, like the 2 or 9, or like the plus, the 61 for the end of the world. And the reason I'm doing that is to make it obvious that they diverge. But in principle, you can actually align your structured and unstructured model relatively close. But your unstructured model will always have this probability of failure, especially for more complicated structured output. So just note that this is not technically fair. So I just want to remark on that. And then we're going to do these 2 things here where I'm going to call this structured. Oops. Yeah. Sorry. Let me revisit. I skipped this part actually, where I actually generate these functions. So we're going to use generate.regex, and this creates a function that accepts some prompt, and it returns something that is consistent with a regular expression. In this case, we're going to give it the model. That's phi3. And then we're going to give it a regular expression, which is +5.6, 2.9, \d4, etc. That's the regular expression that matches Chilean phone number. And then we're going to create an unstructured generator function that just uses .text. This is what you're used to. Anytime you talk to Claude or anytime you call most language models, it typically gives you unstructured text. Even if you use JSON mode is technically unstructured and will generate others. It doesn't have any guarantees. It's more of a fine-tuning thing than anything else. But we're going to compare these 2 functions where this is, we ask this to give me a Chilean phone number and this to give me a Chilean phone number. So back to this, we're actually going to pass our prompt, give me a Chilean phone number, to the structured generator function and the unstructured generator function. And so this is our Chilean phone number, and this is whatever the language model wants to put out. And we're going to ask for only max tokens 100 because this unstructured text will just generate a bunch of stuff because the language model wants to keep going for the most part. This should be exactly a Chilean phone number. And here's the output we get from the structured model, right? It's just this, right? This is the only text that you're going to get. You can take this, you can put it in your database, you can send it to Twilio if you want to do automated texts, things like that. So you know that it's always going to be in this format. Okay, the unstructured model is going to give us a bunch of crap we don't want. I'm sure that you're used to this where you ask your model for something and then Claude is certainly, or whatever. And it started explaining this. It's I don't have the capability. I'm sorry. The country code is +5.6. The area code is something like this. The local number is 7 to 9. It gives me this number. And then it's hidden. It doesn't follow the format we expected. Then it starts doing, please note, you usually need, right? This is just not useful, right? This is we were please just give me some stuff that I need. That, I'm an adult, I want to program with my language model, but you get all this kind of like extra nonsense that you didn't want. So I'll show you quickly some other cool things you can do, because Outlines has a lot more powerful features than this. So one that I like using a lot is just picking from a list of options. Yes, no, maybe, for example, you may have had a case where you want your model to say like, did this user say yes? Did this user say no? Did this user say maybe? And you can force your language model to pick from one of those three. And it will only output yes, no, or maybe. And that means you can do stuff like if, else, or whatever. That works pretty well in case you want to do miscategorization stuff. So like classifying papers as like types of papers, what literatures they're involved in, that kind of stuff. So any type of categorization problem, you can use true, false, unclear. If you have like a language model as a judge that like does fact checking on another model, you can give it some information and it can say like, did this model say, is this true, false, unclear? According to the information, look at another language model output and verify it. You can do that kind of stuff. And even solving riddles. So I've got this like simple riddle here, which is Smith teaches biology or chemistry. Jones teaches the subject that Smith doesn't teach. If the biology teacher wears glasses and Jones doesn't wear glasses, who teaches biology? Right. So this is kind of like a dumb thing you can solve. You can kind of like induce, understand who did this. And we have two characters in here, Smith and Jones. And the model has to pick from Smith or Jones, right? It can't give me Jerry. It can't be like, I can't say like Smith seems to be the person who does this. And here's why. And so I'm going to use generate.choice here. This is another option inside of Outlines. We're going to give it the model. And then the choices it's allowed to select from, either Smith or Jones. Then we're going to generate a response here, which is this is a function that takes any string and returns either Smith or Jones. Can't return anything other than Smith or Jones. Then we're going to pass our prompt, and then it'll give us Smith. So because the biology teacher wears glasses and Jones doesn't wear glasses, which means that Smith has to wear glasses. Okay, so it gets it right. It's able to like do the inference here and pick Smith or Jones. So another one that's really powerful, I think of this as kind of the most powerful part of Outlines, and that's generating JSON. And JSON is really valuable as just passing data between various services. You can use it to program with, because something is always going to follow this format. And we can just kind of generally define a JSON schema. And a schema for JSON is something that describes the exact shape of the output that you should get, the exact shape of the JSON you'll get. And Outlines will guarantee that your output matches the JSON that you should get as defined by the schema. So importantly, we can also take this JSON and we can read it into a Python object and use that to program with, right? This is just a native Python object. You do all the things that you normally would. And it's just easy to work with. You don't even have to think about the JSON. Outlines just kind of abstracts all that stuff for you. So here's just a kind of a simple example. We're going to use Pydantic here. If you're not used to Pydantic, it's kind of a package for kind of strongly typing classes. So in this case, we're going to make a person that inherits from Pydantic's base model. We're going to give it a name and tell it that it's going to be a string, and then an age, which is going to be an integer. And then I'm going to give it this prompt, which is, my name is Cameron. I was 30, but my birthday was yesterday. What is my name and age? Respond in JSON. So note here that this requires a little bit of an inference trick, right? It has to see that my birthday was yesterday and infer that that must have made me 31. Okay, and this part here, respond in JSON, you don't technically have to do this. Your model will always output JSON, but you still have to do good prompting, right? Like the quality inside of the JSON that you're going to get matters. The prompting matters. And so telling it what to expect in advance helps the model know that it's going to print out some JSON, so it's prepared for it. So it usually helps to describe what it's going to get, give me a name and an age, etc. So just remember that you still have to do prompting, but you will get the format that you asked for. So we're going to get a person generator here, which we're going to use generate.json. We're going to give it a model and then a person, right? We're going to give it this class definition here. And that means this person generator function will take any string and return a person object. Because we're going to take the underlying JSON, convert it into a person, and then we can use that for whatever we want. So person here is going to be the person that we extracted from the prompt. And we can see here on the bottom, this is the output. It gives us a person with name Cameron, and importantly, age 31. It was able to do the understanding that it needs to give me 31, and it gave me an integer. Okay. So I thought that was kind of fun. If you're interested, this is the underlying JSON schema. JSON schema is like kind of a standard for typing JSON. So we know that it has to have a name and an age. Name is string, type age is integer, and you must provide name and age. They're in the required field. And we know that we have to get a JSON object back. Okay. So this is just kind of defining it. And when we go to the language model, the thing that the language model actually generates is JSON. So this gives us our name. Name is a key and age as a key with 31 as our value. Right. So this is what you actually get from the language model. And then we convert it into a Python class, Python object. You can also use nested objects. So you can actually create kind of arbitrarily complicated Python, Python pedantic classes. And you can actually extract a lot of information in one call. I don't have a big example here, but we have some like bigger examples in our demos repo and on like our cookbooks and the documentation side. So here's just kind of an example of extracting some additional information. So I'm going to decide to add a US address class. And we have a street, a city, and these are unconstrained to be any string, right? So it can be, whatever street, whatever city. Then we have state, and that's going to be a string. But you'll notice here I have this field thing here, and I give it the pattern argument. What that means is it constrains state to follow a regular expression defined here. And this just means 2 capital letters between A and Z, and then 2 digits, and 2 of those capital letters. So typically, New York State is denoted with NY, or Oregon, my home state, is OR, for example. So we're saying the language model, you have to give me the state in this consistent format. Don't give me like a mix of state values and like the actual full name of the state. Just give me the 2 letters. And then we have zip codes, and I also constrain those to be 5 digits. And zip code is just a 5-digit number that gives you like a rough region of where you are in the US. So like where I grew up was 97007. That was my zip code. Then I'm going to redefine this person class here. And person is going to have a name, which is an unstructured string, and then an age. And you'll note here that I put optional with brackets around the integer, which basically means that we can have either an integer or missing, basically. And we're going to let it default to none. I'll show you why that's important in a second. And then we're actually going to put this class, this US address, inside of an address field inside of person. So person is actually nested classes, right? It has all of the name and age, and then it has an address field, like a little subclass that it can pull in. And that's a US address class. Sorry, I just got someone trying to get into my door. Presumably it's an Amazon person. Anyway, so I'm going to give it this prompt, which is, my name is Cameron. I live at 123 Main Street. My town is called Anytown. It's quiet but cute. I didn't expect to be living in New York, but I'm enjoying it. So I've given it kind of all the information that I asked for here, except for age. Notice that I've omitted age. And then I say, anyway, my zip code is 12345, because I couldn't find a quick way to shoehorn it in here. So I just said, anyway, my zip code is blah, blah, blah. So then we're going to create this person generator again. So generate.json, we're going to give it a person, which tells the person generator function to give me a person back. And then the thing we extract when we pass it the prompt is this. And so we get a person. We have the name, Cameron, that was in the prompt. Age is none, because I didn't give it an age. So it was allowed to omit it. And this is actually kind of important, because if I left it non-optional and then I didn't specify an age, your model would just invent an age because it has to give you an integer. And so this is actually good practice, as you can kind of like define what things you expect to be in the data or the prompt that you provide it. And you can just kind of be very specific about the kind of stuff that you expect to your input and the stuff that you expect to see in your output. And then we got this US address thing. And you'll note I said in the prompt, I said New York, but I didn't say NY. But because we restricted it to be NY, any 2 digits, it gave me NY. And then we have our zip code 12345, again, because I specified that it had to be 5 digits. And note that it's a string here because I said it was a string. Okay. So great. This is like a thing we can program with. This is just a Python object. So we can do like if name equals Cameron. I can look up my name in the database. I can insert the age into the database. I can like check the address to see if anyone works there, things like that. Or if anyone lives there that we have previously, stuff like that. We can just do anything we want to with this that you normally would in a standard program. So I'll give you like kind of the key takeaways here is that outlines and structured generation specifically give you the ability to make your AI speak the language of your application and kind of any application, right? This is a thing that you should consider building into any project that uses language models. So language models are really unreliable, and it is really useful to be able to tell your language model, like, buddy, we're working here. Like you have to output something that looks like a phone number, or you have to output something that looks like this class. And so structured generation lets you control the output of a language model. And that's all it does. It just says like, all right, you have these things you can choose from, like ignore everything else, just pick ones that I expect you to pick from. So this works with regular expression, JSON, CSV, choices, context-free grammars. We have an example on the site that does like image extraction. So you can take a picture of something and then extract structured data from it. You do all this like very cool stuff. Anything that has language model input where you have open weights, you can use outlines. And it's easy to integrate with Python, as we saw, or anything that uses text. So if you're using VLLM servers and you request structured output from it, it will give you text back that was formatted typically using outlines. There's options to use other backends, but by default, it uses outlines. And you can accept that text anywhere. So if you're on a TypeScript thing and you call out to something using like the OpenAI SDK, you can actually just hijack it to point at your VLLM server and get standard structured output back. So that's if you need some kind of outline support on the cloud inference side. So if you want to try it out, pip install outlines. You can also check out our documentation, and we have examples and cookbooks and things like that. So go on and check it out. If you have questions, you can go to our Discord. I don't think I have an example here, but it's on our website. It's on the repo. You can find it anywhere. So those are our QR codes, but we can share some of that stuff later. So yeah, I'm going to go ahead and stop sharing here and go back to hanging out with the Alonsos. Hello.
Hi. Hey.
Hi.
Thank you so much for your talk.
You needed to put the blue sky also.
Oh yeah, we need to put our blue sky on. Yeah, so
but you do have blue sky.
We do have blue sky. I'm a big fan of blue sky. So it's just .txt-ai.bluesky.social. We're probably going to change it to use our personal URL because you can do that in blue sky. So come and hang out with us.
Yeah. We have a lot of questions in the chat. So
let's do some questions. I love questions.
Yeah, the first one.
How can I measure the impact of using Pydantic models inside prompts versus not using Pydantic? I'm not totally sure I understand this question. Like, I think my understanding would be if you provide the structure of the Pydantic model inside of the prompt, I think it's difficult to measure. Like a lot of language model stuff is hard to measure, but anecdotally, we can say that it makes your output better. I typically pass the schema or tell it what to expect, especially for really large schemas, just because the language model like may preemptively, like it may try and start filling out JSON inside of strings if it doesn't know that it should expect that there's a field later that it can fill out. So just anecdotally, it works significantly better, especially for more complicated schemas.
Nice. And the second one, Daniel?
If the next token that is required doesn't appear in the available logits. If this is the case, I hate to say it, but it's user error. So if the next token that you need doesn't show up there, it's because you either have too restrictive, like a regular expression, or a structure. The token that you need that is valid according to the pattern that you specify has to show up inside of the available logits. If it's not there, then you may need to adjust something on like the regular expression side, or how your your Pydantic thing is set up. So that could be the cases, but I hate to say user error because it's kind of mean.
And the second one from Daniel.
Okay, thank you, Daniel, for the questions. In your experience, does it usually help to add additional throwaway fields? For example, an explanation field when you plan to throw it away. Yes, I do this all the time. So this is a trick I learned from Alonso Silva, where he basically adds like chain of thought or reasoning steps or whatever. I've even added fields where I add like reflect on your description, and then conclusion, whether this needs to be redone. So like you can add all kinds of stuff that you may not intend to use that can guide the model to doing things better. I had like key observations. I have to just summarize stuff. You can add a bunch of stuff that kind of helps your model understand what it needs to print later. So I love that. I love that technique.
So we don't have any more chat questions, but Alonso, do you have anyone?
No, perhaps a comment. No, related to the Pydantic schema, I definitely I feel I get the same feeling that it really helps, and that's why.
Oh, go ahead. Sorry.
No, I wanted to just say, like some people mention, but this is like similar to Instructure, and I don't feel like it's the same. But in some way, so Instructure many times they use function calling and they provide a JSON schema and stuff like that. And you can combine both. I mean, there is no reason why not provide the Pydantic schema, tell it to use function calling, and at the same time restricting the output to fulfill the requirement that you are giving it.
Yeah, exactly.
That's in that direction is my question, because I know a lot of LLMs API providers has like a JSON mode. And what is it different from this? I know the answer, but I want the.
I think I appreciate you bringing this up, because like this is the fight that I'm like on a lot, where people are like, oh yeah, JSON mode didn't give me the result I expected. And the reason for that is that JSON mode is not structured generation. JSON mode is like it's basically a fine tune. Like you tell it to do JSON mode, and then some models that have JSON mode are like, okay, I need to start printing JSON. If you have anything like a mildly complicated schema, JSON mode will just fail. Or sometimes it just like reorders things. It doesn't care about the type. It'll miss commas and quotes and things like that. So you don't have the guarantees that you get with formal structured generation. So a lot of model providers still have this as a legacy solution. Structured generation is like still kind of coming on with like large model providers. So like if you use a model provider who does open weights, please send them an email and say like, can you give me the good stuff? And we'd be happy to help them out with that.
Yeah, Daniel has another question about this. And I recommend your blog, the Tactics blog, because it's amazing and talk about a lot about this. But
Karpathy recommended, so.
Yeah, Karpathy recently recommended our blog, which means it's popular now. So we've got plenty of cool stuff. We write kind of like some like technical stuff about like how language models work and like how structured generation can work and speed and all that stuff. So if you're interested in that, go check out the blog.
Yeah, and people is talking about the chain of thought, I think, but we can link your.
Yeah, we can put that in the. Alonso has a good cookbook about this, like chain of thought, and you've also got like a React kind of specification. So there's like plenty of stuff in there about just like adding.
Yes, very powerful.
Yeah. I've also got some demos here. Let me actually put that in the. I'll put this in the box. So if you want, do I have to join the chat? Oh, I have to connect my YouTube.
But you have comment section here in.
Oh, okay. Oh, I have to like log into YouTube to.
Weird.
Okay.
But
okay. Well, we can put up the like demos thing. Actually, here, let me send it to you. I'll put it in the Discord. But yeah. So the chain of thought stuff is pretty easy to do. So Alonso, I sent you something on Discord. I don't know if you can put that in the comments for me, but we have like a repo called demos that is just like bigger, more complicated stuff. So if you want to see like kind of basic applications, like you want to do RAG, you want to do like image processing, you want to do like, I've got some chain of thought stuff in there. So if you want to work with like reasoning steps or reflection or whatever, you can do all that stuff in there. And I hope that inspires stuff. But if you've got questions, you can come to the Discord. And I'm happy to help out there.
It's a very active community there.
Yeah, it started picking up a lot lately. I've been really happy with it.
Yeah, and I have a final question because a bit off topic, but I want to ask this because you live in San Francisco, like it's a different planet in the AI topic, and we here in Chile we have a crazy ChatGPT adoption and all of the LLMs based tools, but there are very few people actually building LLM stuff. Yeah. And other university, we are starting a software engineer program focused on AI, and people are like, "You're crazy! It's just hype." What's your opinion on that?
Oh, the hype stuff. I mean, there's definitely some hype. Like, I'm not going to say that there's no hype. Like, it is like a hypey thing. I think people are still trying to figure out the impact it has on jobs and careers and like the future of various fields. And I think all of that stuff is like a serious consideration. But like, I would say 60 to 80% of the code I write now is language model generated. I don't write code anymore. I am a manager. I manage code. And even just in the programming world, it's enormous. But like, I've seen anecdotal stuff of like people who are writers. They write marketing content for blogs, and like people don't need them. Like they've been like fired, or they have to work a lot less or whatever, because like language models can just write kind of like quick content. And I do think it's seriously important to like sit down and be like, how does this affect my career? And like, how can I like work with some of these models and figuring out how to use these as tools? I work in AI, so I'm like, don't take my, I'm a little biased, but I do think it's important. I do think it's going to change people's lives in a kind of a significant way.
Yeah, of course. Well, thank you so much for your talk. It was amazing.
Thank you for having me. I appreciate it.
Great. Thank you. Thank you very much.
Yeah, of course.
Thank you to the audience. We had a lot of questions, so that was fun. And see you in the next week and in the conference. The people of Santiago, please go to the conference and we can meet in person. So, bye. Thank you, Cameron. Thank you, Alonso.
Thank you, Cameron.
Thanks,
Thank you,
everyone.
Alonso. Bye.